fresh air with its life-supporting oxygen, you realize how important it is when you're down here.
When you're on the ground, that rock temperature is 100 or 140 degrees. You got to have air. When you ain't getting it, mister, you know it.
You feel weak, hungry, your strength's gone.
Man, when the air's close, brother, you can tell.
Sometimes you can tell, sometimes you can't. A rescue team was sent to investigate the failure of 3 men to return from the night shift of a sulfide copper mine. They spotted the lights of the men's loader. Their workplace had been an unventilated opening, a dead end with no forced ventilation or air circulation. The running engine, which consumed much of the oxygen, plus the exhaust fumes, resulted in their deaths. With suffocation listed as the cause, autopsies would show 78% carbon monoxide saturation in blood samples of the deceased. Fatalities caused by asphyxiation in metal and non-metal mines do not happen often, but even a single death is one too many. Not long ago, in an ore mine, a drill struck a water course. When water, under pressure, was released into the drift, work had to be halted. The next day, a miner went in to inspect the water flow. Hydrogen sulfide gas. Its immediate effects are eye irritation and tightness in the chest, and it has an odor of rotten eggs. But under high concentration, this is not detectable, for the sense of smell is quickly paralyzed. The condition was reported, but adequate precautions were not taken. Over the weekend, one of the fans failed, allowing an accumulation of the gas to build up. Monday morning, while it was being repaired, a miner entered the drift to recover a tool. He never returned. A half hour later, 2 other miners went in after it. When neither of them returned, another miner entered, and before it was over, 3 more had died, bringing the toll to 7. In another recent incident, a couple of workmen were sent to repair a slusher in a sublevel. As work progressed, the young helper wandered off. The lead man went about his work. But before long, he noticed that his partner was not with him. He finally found him at the next sub-level, where he had wandered into an inactive, unventilated area which should have been sealed or barricaded and posted against entry. This young miner would never wander again. How can these underground accidents be prevented? Up here, you seldom think about air. It's everywhere. Down below, it can be a life or death problem. It's largely up to you whether or not you return to the surface.
Working in a...
Sure, the ventilation system is the responsibility of management. Management must install, maintain, and repair the system, but it's your responsibility to know how it works and how to use it properly. Make yourself familiar with the entire ventilation system, and especially the ventilation in your working section. Every underground mine, whether metal or non-metal, deep or shallow, mining by room and pillar methods, block caving, or cut and fill, operates on the principle of air either being blown into or exhausted from the mine. Main fans, along with inline booster fans or natural ventilation pressure, generate the mine's fresh air supply. In the headings and other work areas, auxiliary fans draw a portion of the fresh air from the primary circuit, providing enough cubic feet of air per minute for you to do your job and stay healthy. Intake air, the main fresh air course. Return or contaminated air being exhausted out of the mine. These are the two components around which the ventilation plan is designed. If for any reason a bulkhead or ventilation door is removed or damaged by blasting, these systems will be short-circuited, thereby contaminating the mine's fresh air supply. To guard against this, there are all sorts of devices to control the airflow to get it to the work areas. Ventilation doors, bulkheads, overcasts and undercasts, brattice lines, ventilation tubing, and various kinds of stoppings and regulators. Be aware of the ventilation system. Know its parts and their usefulness. The ventilation system is a balanced system. Any changes you make in it could adversely affect yourself or others. This slusherman feels that he is not getting enough air. By opening the ventilation regulator, he gets his air all right, but how does he affect the men in the next scram? With suction impeded, the drift does not draw as well, resulting in these men being deprived of their share of air. Never change the balance in the system by removing or adding a restriction. If a door is left open in an airway, much of the air volume is lost instead of it going to your fellow miners. When you are hot and tired, the temptation to tamper with vent tubing is hard to resist. The result of these changes in the vent system is that one miner becomes hotter and more fatigued, while the others feel better, unaware that they have neglected to look out for the welfare of their fellow miners. Because this fan was blowing on an idle stope face, this miner, who had been working in an adjacent area, turned it off. On the next shift, when the crew came on, they walked into, well, a virtual inferno. Avoid tampering with fans. They are part of the balanced system. If a fan draft or noise interferes with your comfort, Move somewhere else. Do not turn it off. It's the responsibility of management and the service or utility crew to install vent tubing, but it's your job to see that it works. To see that it is properly suspended. To take out any kinks and repair any leaks. To keep advancing the tubing as you advance. To install any necessary elbows. And to pull tubing ends out of the way at blasting time. After blasting and before the men re-enter the work area, sufficient air must be provided to clear the area of dust and fumes. Be sure to wait in the fresh air stream, away from the exhaust air site. In many mines, the procedure is to blast between shifts or during lunch. Allowing time for the atmosphere to clear before re-entering. To help ensure good air in a blasted area, wet down the muck pile before going to work. Otherwise, trapped dust and fumes may become airborne, entering the moving airstream and damaging the air quality for yourself and for others. The odds are 99 to 1 that you will breathe good air, shift in, shift out, week after week, year after year. It's that 1% we have to wipe out.
You can't depend on your sense of feel or smell. They can only indicate trouble.
He's right. Do check your area before going to work, but don't depend too much on your own monitoring tools, your sense of feel and smell. Get an air measurement. Most mines, big and small, have the best ventilation engineering possible, and experienced mine supervisors, as well as state and federal inspectors making regular air quality tests. These tests can accurately tell whether the air is too close, too hot, or too gassy. Never take the air you breathe for granted. Keep checking wherever you work. Keep in mind that in all dead ends, particularly in active drifts, raises, and windses, you may encounter oxygen-deficient air. Check it, and before working in such an area, be sure to ventilate it. The effects of an oxygen-deficient atmosphere may be felt in a very short time, sometimes in only a few seconds.
Hello, David. How's it going? Oh, pretty good.
Don't work in a bad atmosphere. Report it to your shift boss.
It's pretty bad down there. But we're going to need a little bit better air down there before we can go back to work. Okay, we'll take care of it. Right away.
Immediately report any problems.
A tram wrecked into the bulkhead by the face. The vent tubing near number 3 stope is damaged.
Fan near the machine shop isn't working right.
These problems could affect your air or the air for your fellow miners. Some mines depend heavily on diesel-powered machines for many of their underground operations. Machines which, if not properly maintained, can excessively contaminate the airstream with oxides of nitrogen, carbon monoxide, and carbon dioxide. Most of these diesels are equipped with catalytic exhaust conditioners or scrubbers to reduce the hazards of toxic exhaust gases. Nevertheless, stay on the alert. If you suspect something wrong in the air, ask your unit foreman for an air check. Above all, never leave your machine with the engine idling in a confined area. scrubbers are no guarantee against carbon monoxide poisoning. Fires can create special ventilation problems underground. And even though every mine has its own fire emergency plan, it's up to you to learn the role that ventilation plays as well as your own escape route. In this particular mine, the intake air is coming down the number 1 shaft and borehole and traveling over to the number 2 shaft. Note the booster fan at this level. Suppose a fire started in the shop area on B level. The escape route for the men in the shop is relatively simple. Using self-rescuers, they would head out this way to the shaft station and the hoist. Most important, however, they would remember to close this air door after themselves to prevent oxygen from feeding the fire. But what about the men working on this lowest level? Their escape route is more complicated because at this end of the mine, between B and C levels, there is only a ventilation borehole. First, they would be sure to cut off the booster fan to prevent air recirculation and the fire from spreading. Then they would go out this way, through shaft number 3 until reaching A level. From this level, they would reach the number 1 shaft and take the cage out. Escape routes and emergency plans will vary according to where you work. It's your job to learn not only your particular route, but what you must do before going out.
In any of your escape route plans.
Asphyxiation. They say it's like drowning. Man, I want no part of that.
Nobody does. And through engineering, a lot has been done to control ventilation in mines, such as using mechanically operated doors to help distribute air from the same source to a number of headings. Roll-up doors to help control airflow. Heating units to warm frigid winter air. Refrigerator units which can cool and dehumidify 100-degree summer heat. And huge evaporative cooling towers for changing surface air that is to be blown into deep, hot mines. But given this engineering progress, good ventilation is the result of the way you, the miner, make use of the tools for providing good air. Fresh air to breathe and live.